In the reproductive unit, we're going to cover the male reproductive system, both internal and external. And then in the second standard, we'll talk about female reproductive. And then the third, we'll discuss birth control as well as menstruation. So for your OVUM.1 standard, it reads, I can describe the structure and function of each part of the male reproductive system. All right, Unit 15, reproductive. Overall, what we're trying to do is regulate reproduction by creating sex cells, also known as gametes, by transporting them where they need to be, and then in the female, we're also hosting fertilization. So we are creating a womb, creating a safe space of growth for that developing fetus. Your OVUM.1 standard first talks about the male reproductive system, and we have to first discuss the primary sex organ. So there are multiple sex organs in both males and females, comprised of different tissues having different roles, but the primary one is the one that creates the sex cells. So what we're trying to do here is create cells that have half as many chromosomes as a normal human cell does. So instead of 46, we want cells with only 23. That will allow us to bring two gametes together to produce a human with a full set of 46 chromosomes, half from mom, half from dad. So this primary sex hormone is not the penis in the male, it's the testes themselves. So most men are born with two, and the primary function is to produce these precursors to sperm. They're called spermatozoa, and that process by which we build them is spermatogenesis. A secondary function is also to create the male hormone, so testosterone, other androgens that are responsible for secondary male sex characteristics are produced here in the testes as well. So here's an overview of spermatogenesis. We are born with a set of stem cells in our testes that constantly regenerate themselves. And then when triggered to do so, they can mature into sperm cells. But we always have a host of stem cells continuing to divide and replenish. So in the first round of division, meiosis 1, that's when we cut our chromosome number in half. So if this were a human, we'd go from 46 down to 23. Meiosis 2, all we're doing is creating two cells from one. We're just dividing, but we're preserving that chromosome number of 23, which you can't divide evenly anyway. Over time, these cells will mature into sperm by acquiring the tail, the little flagellum, as well as the pointy head, and we'll discuss the anatomy of a sperm in a moment. So, like we saw in the previous slide, there are four primary components to a sperm. So that pointy head is not just filled with DNA, it actually has enzymes that will be secreted if the sperm is lucky enough to make it to the egg and will help it penetrate the oocytes, which is a fancy word for egg. So that is the acrosome. It's situated right on top of the head of the sperm. Within the head of the sperm, we have our nucleus. There is very little cytoplasm in a sperm. I believe it's the smallest human cell. And so right here, we just have our 23 chromosomes pretty tightly packaged. In the midpiece, we do need power. And so powerhouse of the cell, the mitochondria are going to exist here in the midpiece, breaking down glucose, using oxygen to create ATP. And that is primarily for the last piece, the tail. That tail contains microtubules that spin, and that allows it to propel the sperm towards the egg. So we've created a cell here that does not have very much function aside from what it is designed to do. It's designed to move, it's designed to power through, and to make it to the egg cell and eventually hopefully penetrate it. Though in a standard ejaculation there are several hundred million sperm, so if that sperm is lucky enough to be one in several hundred million, it can finally penetrate the egg. For internal anatomy, so what we're seeing here, this is more external male anatomy. In the internal male anatomy, what we're trying to do is produce and deliver semen. So semen is a little bit different than sperm because it contains sperm mixed together with other secretions for lubrication. The pH of semen is basic. It's a little bit above 7, about 7.5, and that's because the vagina is acidic, and so this lubrication will help protect the sperm once they enter. The average volume per ejaculation is about 2 to 5 milliliters, and as I mentioned, there are hundreds of millions of sperm on average per milliliter of semen. These are the parts of the internal anatomy we have to label. So what we've done is we've taken the scrotum away, we've separated the right and left testes, we've taken the skin off of the penis, and then we can see some things on the inside here. The urinary bladder is situated right in the middle of everything else. So we see our ureters, our urinary bladder, and in the last unit we talked about what the urethra was for delivering urine out of the body. This is going to be a multi-use organ. Unlike the female reproductive anatomy, the sex cells and the urine are going to both come out of the urethra. So I've underlined the structures that tie into specifically the reproductive system that I'm going to cover. So first, in our testes, we create the sperm, and we're going to follow a path of sperm through these internal structures. So they're created here via the process of spermatogenesis, and then they mature in this bumpy ridge that lines the testes called the epididymis. From there, we have these long tubules that run up the back of the testes, up on top of the urinary bladder, and eventually towards some glands here and some vesicles. This long tubule is called the vas deferens or the ductus deferens. I've typically heard vas deferens. From there, we're going to pick up some lubricating liquids. So the seminal vesicles look like this pair of cloudy wings, and they produce most of the fluid that will eventually form the semen. A lot of that very basic fluid to protect them is secreted here. So this was mostly pure sperm coming down, and now we've added in some lubricant. We'll pass through the prostate gland, which helps secrete even more, this time milkier white alkaline fluid. And some of these secretions also help the sperm move a little bit more and increase the overall semen volume. From there, the last little gland we'll pass through is the bulbourethral gland, and that is going to secrete fluid in response to any sexual stimulation to help lubricate the urethra and the penis to aid in both sexual intercourse as well as delivery of semen. Finally, the urethra will receive complete semen, and upon orgasm, that semen will leave out through the urethra. Externally, what we're trying to do is deliver that semen out of the penis and also protect the internal reproductive organs. So this is like a side view. We still see the testes, the vas deferens, the bladder, the urethra. It's all here. So the scrotum is that pouch of skin that holds the testes, and it's lined with a little bit of smooth muscle, and they are able to contract or relax in response to temperature. So sperm wants to be about 5 degrees Fahrenheit below the normal human body temperature of 98.6. And so when a man is hot, his testes will hang out away from his body. And when he's cold, that muscle will contract a little bit and the testes will get pulled back in towards the body, ultimately trying to keep sperm at an optimal temperature. The penis is for conveying both urine, but in this system, semen out of the body. There's a large distal enlargement on the end of the penis called the glans penis, which has a very high sensitivity of nerve endings, and is often, well, all the time when men are born, covered in a structure called foreskin. Some men, particularly men here in the United States, have this foreskin removed because it can reduce risks of penile cancer, it can reduce STD transmission, or it can be done culturally. But ultimately, a lot of men, the majority of the world, is uncircumcised and still has this foreskin, which apparently there are some benefits that lead to more sensitive sexual stimulation and the need for less lubricant. Finally, when a man reaches erection, that's when he is sexually stimulated enough that his nerve endings start to tell the arteries to open up. So when the penis gets erect, it's filling with blood. There are no bones in the penis. It's all just erectile spongy tissue. And when that blood accumulates, more blood is entering than is exiting, and that causes the penis to swell and elongate. Upon culmination of sexual stimulation, there's a pleasurable orgasm that's accompanied by emission and ejaculation. So emission is when the semen loads into the urethra, like just below it. It's when it moves towards it. And then ejaculation is when it leaves the urethra, hoping to find an egg to fertilize. Lastly, for the male reproductive system, we said the testes produce male hormones, and I'm just going to talk about testosterone. So when we're talking about biological males, the primary sex characteristic is that they have testes and a lot of those internal structures that we mentioned. But there are a lot of secondary sexual characteristics that can be used to attract partners or denote maleness. And that would be an increase in body hair, which is caused by testosterone, thicker vocal cords producing a deeper vocal tone, again testosterone, and an increase in muscle tone. The last thing I want to leave you with, because we don't have case studies in this unit, is just this model, Aidan Dowling. He is a trans man who has been exposed to testosterone for a couple years. And so this was what he looked like before transition, and then this is what he looked like after after transition. He is famous for being a fitness model. He was on the cover of Men's Health magazine. We can also see that aside from the testosterone giving him chest hair and facial hair, muscle tone, he has had at least one surgery to remove his breast tissue, as testosterone alone is not enough to remove breast tissue.